This is a glossary of set theory. Greek. Alpha often used for and ordinal beta. Beta x is the Stonecheck compactification of x gamma, a gamma number, an ordinal of the form omega alpha gamma, the gamma function of ordinals. In particular, gamma 0 is the Pfefferman-Schutt ordinal. Delta an a delta number, an ordinal of the form omega alpha delta 1. A set of formulas in the Elie-Acute-Vy hierarchy 2. A delta system epsilon, an epsilon number, an ordinal with omega epsilon equals epsilon eta 1. The order type of the rational numbers, chapter 2. An eta set, a type of ordered set theta. The order type of the real numbers theta, the supremum of the ordinals that are the image of a function from omega kappa 1. Often used for a cardinal, especially the critical point of an elementary embedding 2. The Erdos cardinal kappa is the smallest cardinal such that kappa less than omega lambda 1. Often used for a cardinal 2. The order type of the real numbers mu a measured pi 1. A product of cardinals 2. A set of formulas in the Elie-Acute-Vy hierarchy. Rho, the rank of a set. Sigma countable, as in sigma compact, sigma complete and so on. Sigma 1. A sum of cardinals 2. A set of formulas in the Elie-Acute-Vy hierarchy. Phi a Veblen function omega 1. The smallest infinite ordinal 2. Omega alpha is an alternative name for alpha, used when it is considered as an ordinal number rather than a cardinal number. Omega 1. The class of all ordinals, related to Cantor's absolute 2. Omega logic is a form of logic introduced by Hugh Wooden. $it equals standard set theory symbols with their usual meanings, standard logical symbols with their usual meanings, and equivalence relation. Fx is now the restriction of a function or relation f to some set x. Though its original meaning was the co-restriction, Fx is the restriction of a function or relation f to some set x increment 1. The symmetric difference of two sets 2. A diagonal intersection, the diamond principle, a club suit principle, the square principle. The composition of functions Sx is the extension of a sequence S by x plus 1. Addition of ordinals 2. Addition of cardinals 3. Alpha plus is the smallest cardinal greater than alpha 4. B plus is the poset of non-zero elements of a Boolean algebra. B5. The inclusive or operation in a Boolean algebra. Tilde 1. The difference of two sets. X tilde y is the set of elements of x not in y. 2. An equivalence relation. The difference of two sets. X, y is the set of elements of x not in y, minus the difference of two sets. X minus y is the set of elements of x not in y, has the same cardinality as times a product of sets, a quotient of a set by an equivalence relation 1. Xy is the ordinal products of two ordinals 2. Xy is the cardinal product of two cardinals. Asterisk, an operation that takes a forcing poset and a name for a forcing poset and produces a new forcing poset. Infinity, the class of all ordinals, or at least something larger than all ordinals. Alpha beta 1. Cardinal exponentiation 2. Ordinal exponentiation beta alpha 1. The set of functions from beta to alpha 1 implies 2. F x y means f is a function from x to y. 3. The ordinary partition symbol, where kappa nm means that for every coloring of the n elements subsets of kappa with m colors there is a subset of size lambda, all of whose n elements subsets are the same color. F x, if there is a unique y such that x y is in F, then f x is y, otherwise it is the empty set. So if f is a function and x is in its domain, then f x is f. F x is the image of a set x by f. If f is a function whose domain contains x, this is f x 1. M G is the smallest model of ZF containing G and all elements of M. 2. Alpha beta is the set of all subsets of a set alpha of cardinality beta, or of an ordered set alpha of order type beta. 3. X is the equivalence class of X. 1. A B is the set with elements A, B. 2. X Phi is the set of X such that Phi B is an ordered pair. And similarly for ordered n-tuples X, the cardinality of a set X, phi, the value of a formula phi in some Boolean algebra phi is the Gödel number of a formula phi. A phi means that the formula phi follows from the theory A phi means that the formula phi holds in the model A. The forcing relation. An elementary embedding PQ means that P and Q are incompatible elements of a partial order 0 sharp. The set of true formulas about indiscernibles and order indiscernibles in the constructible universe 00 dagger. A certain set of true formulas, the Hebrew letter Aleph, which indexes the Aleph numbers or infinite cardinals, alpha, the Hebrew letter Beth, which indexes the Beth numbers alpha, a serif form of the Hebrew letter Gimel, representing the Gimel function, the Hebrew letter Tor, used by Cantor for the class of all cardinal numbers A, the least size of a maximal almost disjoint family of infinite subsets of omega A. The Suslin operation absolute 1. A statement is called absolute if its truth in some model implies its truth in certain related models. 2. Cantor's absolute is a somewhat unclear concept sometimes used to mean the class of all sets. 3. Cantor's absolute infinite omega is a somewhat unclear concept related to the class of all ordinals AC. 1. AC is the axiom of choice. 2. AC omega is the axiom of countable choice. AD, the axiom of determinacy. Admissible. An admissible set is a model of Kripke-Platek set theory, and an admissible ordinal is an ordinal alpha such that L alpha is an admissible set. R Aleph hypothesis, a form of the generalized continuum hypothesis. Aleph 1, an infinite cardinal. 2. The Aleph function taking ordinals to infinite cardinals. Almost universal. A class is called almost universal if every subset of it is contained in some member of it. Amenable. An amenable set is a set that is a model of Kripke-Platek set theory without the axiom of collection. Analytic. An analytic set is the continuous image of a Polish space. Analytical. The analytical hierarchy is a hierarchy of subsets of an effective Polish space. They are definable by a second-order formula without parameters, and an analytical set is a set in the analytical hierarchy. Antichain. An antichain is a set of pairwise incompatible elements of opposite arithmetical. The arithmetical hierarchy is a hierarchy of subsets of a Polish space that can be defined by first-order formulas. Aaronson 1. Nachman. Aaronson 2. An Aaronson tree is an uncountable tree such that all branches and levels are countable. More generally, a kappa Aaronson tree is a tree of cardinality kappa such that all branches and levels have cardinality less than kappa atom 1. A new element, something that is not a set but allowed to be an element of a set. 2. An element of opposites such that any two elements smaller than it are compatible. 3. A set of positive measures such that every measurable subset has the same measure or measure 0. Axiom. Axel's anti-foundation axiom states that every accessible pointed directed graph corresponds to a unique set AD plus an extension of the axiom of determinacy. Axiom of adjunction. Adjoining a set to another set produces a set. Axiom of amalgamation. The union of all elements of a set is a set. Same as axiom of union. Axiom of choice. The product of any set of non-empty sets is non-empty. Axiom of collection. This can mean either the axiom of replacement or the axiom of separation. Axiom of comprehension. The class of all sets with a given property is a set, usually contradictory. Axiom of constructability. Any set is constructible, often abbreviated as V equals L. Axiom of countability. Every set is hereditarily countable. Axiom of countable choice. The product of a countable number of non-empty sets is non-empty. Axiom of dependent choice. A weak form of the axiom of choice. Axiom of determinacy. Certain games are determined In other words, one player has a winning strategy. Axiom of empty set. The empty set exists. Axiom of extensionality or axiom of extent. Axiom of foundation, same as axiom of regularity. Axiom of global choice, there is a global choice function. Axiom of heredity. Axiom of infinity, there is an infinite set. Axiom of limitation of size, a class is a set if and only if it has smaller cardinality than the class of all sets. Axiom of pairing, unordered pairs of sets are sets. Axiom of power set, the power set of any set is a set. Axiom of projective determinacy, certain games given by projective set are determined. In other words, one player has a winning strategy. Axiom of real determinacy, certain games are determined. In other words, one player has a winning strategy. Axiom of regularity, sets are well-founded. Axiom of replacement, the image of a set under a function is a set, same as axiom of substitution. Axiom of subsets, the power set of a set is a set, same as axiom of power sets. Axiom of substitution, the image of a set under a function is a set. Axiom of union, the union of all elements of a set is a set. Axiom schema of predicative separation, axiom of separation for formulas whose quantifiers are bounded. Axiom schema of replacement, the image of a set under a function is a set. Axiom schema of separation, the elements of a set with some property form a set. Axiom schema of specification, the elements of a set with some property form a set, same as axiom schema of separation. Freiling's axiom of symmetry is equivalent to the negation of the continuum hypothesis. Martin's axiom states very roughly that cardinals less than the cardinality of the continuum behave like zero. The proper forcing axiom is a strengthening of Martin's axiom b. The bounding number, the least size of an unbounded family of sequences of natural numbers. A Boolean algebra. Baumgartner's axiom, one of three axioms introduced by Baumgartner. Bear 1. René Louis Bear 2. A subset of a topological space has the Bear property if it differs from an open set by omega set 3. The Bear space is a topological space whose points are sequences of natural numbers. Chapter 4. A Bear space is a topological space such that every intersection of a countable collection of open dense sets is dense. Basic set theory 1. Naive set theory 2. A weak set theory, given by Kripke-Platek set theory without the axiom of collection. Bernays 1. Paul Bernays 2. Bernays-Gödel's set theory is a set theory with classes. Berry's paradox. Berry's paradox considers the smallest positive integer not definable in 10 words. Berkeley cardinal. A Berkeley cardinal is a cardinal kappa in a model of ZF such that for every transitive set M that includes kappa, there is a non-trivial elementary embedding of M into M with critical point below kappa. B.G. Bernays-Gödel's set theory without the axiom of choice. B.G.C. Bernays-Gödel's set theory with the axiom of choice. Boldface. The Boldface hierarchy is a hierarchy of subsets of a Polish space, definable by second-order formulas with parameters. It includes the Borel sets, analytic sets, and projective sets. Boolean algebra. A Boolean algebra is a commutative ring such that all elements satisfy x2 equals x Borel 1, Emil Borel 2. A Borel set is a set in the smallest sigma algebra containing the open set's bounding number. The bounding number is the least size of an unbounded family of sequences of natural numbers. BP Bear property. BS basic set theory. Borel-Forter 1. Cesare Borel-Forter 2. The Borel-Forter paradox states that the ordinal numbers do not form a set C. See the cardinality of the continuum complement of a set C. The Cantor set. Countable anti-chain condition. Cantor 1. Georg Cantor 2. The Cantor normal form of an ordinal is its base omega expansion. 3. Cantor's paradox says that the power set of a set is larger than the set, which gives a contradiction when applied to the universal set. 4. The Cantor set, a perfect nowhere dense subset of the real line. 5. Cantor's absolute infinite omega is something to do with the class of all ordinals. 6. Cantor's absolute is a somewhat unclear concept sometimes used to mean the class of all sets. 7. Cantor's theorem states that the power set operation increases cardinalities. The cardinality of a set cardinal 1. A cardinal number is an ordinal with more elements than any smaller ordinal cardinality. The number of elements of a set categorical. A theory is called kappa categorical if all models of cardinality kappa are isomorphic. Category 1. A set of first category is the same as a meager set. A set that is the union of a countable number of nowhere-dense sets, and a set of second category is a set that is not of first category. 2. A category in the sense of category theory. CCC countable chain condition. Cf. the cofinality of an ordinal. Ch. the continuum hypothesis. Chain a linearly ordered subset. CL abbreviation for closure of class 1. A class is a collection of sets 2. First-class ordinals are finite ordinals, and second-class ordinals are countable infinite ordinals. Club a contraction of closed unbounded 1. A club set is a closed unbounded subset, often of an ordinal 2. The club filter is the filter of all subsets containing a club set 3. Club suit is a combinatorial principle similar to but weaker than the diamond principle. Coanalytic. A coanalytic set is the complement of an analytic set. Cofinal. A subset of a poset is called cofinal if every element of the poset is at most some element of the subset. Cofinality. The cofinality of a poset is the smallest cardinality of a cofinal subset. Cohen 1. Paul Cohen 2. Cohen forcing is a method for constructing models of ZFC3. A Cohen algebra is a Boolean algebra whose completion is free. Collapsing algebra. A collapsing algebra collapses cardinals between lambda and kappa. Complete 1. Complete set is an old term for transitive set. 2. A theory is called complete if it assigns a truth value to every statement of its language. 3. An ideal is called kappa complete if it is closed under the union of less than kappa elements. 4. A measure is called kappa complete if the union of less than kappa measure 0 sets has measure 5. A linear order is called complete if every non-empty bounded subset has a least upper bound. Con for a theory. T means T is consistent condensation. Lemma Gödel's condensation lemma says that an elementary submodel of an element L alpha of the construcible hierarchy is isomorphic to an element L gamma of the constructible hierarchy. Constructible. A set is called constructible if it is in the constructible universe. Continuum. The continuum is the real line or its cardinality core. A core model is a special sort of inner model generalizing the constructible universe. Countable anti-chain condition. A term used for the countable chain condition by authors who think terminology should be logical. Countable chain condition. The countable chain condition for a poset states that every anti-chain is countable. Critical 1. The critical point kappa of an elementary embedding J is the smallest ordinal kappa with J greater than kappa 2. A critical number of a function J is an ordinal kappa with J equals kappa. This is almost the opposite of the first meaning. CTM countable transitive model. Cumulative hierarchy. A cumulative hierarchy is a sequence of sets indexed by ordinals that satisfies certain conditions and whose union is used as a model of set theory. D. The dominating number of a poset. DC. The axiom of dependent choice. Def. The set of definable subsets of a set. Definable. A subset of a set is called definable set if it is the collection of elements satisfying a sentence in some given language. Delta 1. A delta number is an ordinal of the form omega alpha 2. A delta system, also called a sunflower, is a collection of sets such that any two distinct sets have intersection X for some fixed set X. Enumerable, countable and infinite. Df. The set of definable subsets of a set diagonal intersection if is a sequence of subsets of an ordinal, then the diagonal intersection is diamond principle. Jensen's diamond principle states that there are sets A alpha for alpha less than omega 1 such that for any subset A of omega 1 the set of alpha with A alpha equals A alpha is stationary in omega 1. The domain of a function E E is the membership relation of the set X. Easton's theorem describes the possible behavior of the power set function on regular cardinals. Eats the statement, every Aaronson tree is special, elementary. An elementary embedding is a function preserving all properties describable in the language of set theory. Epsilon 1. An epsilon number isn't ordinal alpha such that alpha equals omega alpha 2. Epsilon 0 is the smallest epsilon number. Erdos 1. Paul Erdos 2. An Erdos cardinal is a large cardinal satisfying a certain partition condition. 3. The Erdos-Rado theorem extends Ramsey's theorem to infinite cardinals of ethereal cardinal. An ethereal cardinal is a type of large cardinal similar in strength to subtle cardinals. Extendable cardinal. A cardinal kappa is called extendable if for all eta there is a non-trivial elementary embedding of E kappa plus eta into some V lambda with critical point kappa extension 1. If R is a relation on a class, then the extension of an element Y is the class of X such that X R Y2. An extension of a model is a larger model containing it extensional 1. A relation R on a class is called extensional if every element Y of the class is determined by its extension 2. A class is called extensional if the relation on the class is extensional F. F and F sigma is a union of a countable number of closed sets Pfefferman-Schutt ordinal. The Pfefferman-Schutt ordinal gamma 0 is in some sense the smallest. In predicative ordinal filter, a filter is a non-empty subset of a poset that is downward directed and upwards closed. Finite intersection property FIP. The finite intersection property, abbreviated FIP, says that the intersection of any finite number of elements of a set is non-empty. First one. A set of first category is the same as a meager set. 1 that is the union of a countable number of nowhere dense sets. 2. An ordinal of the first class is a finite ordinal. 3. An ordinal of the first kind is a successor ordinal. 4. First-order logic allows quantification over elements of a model, but not over subsets. Fedor 1. G. Acute ZA Fedor 2. Fedor's lemma states that a regressive function on a regular uncountable cardinal is constant on a stationary subset.